Okay guys, let's take a look at the handout we received today, which was really all about finding the inverse of logarithmic functions and the inverse of exponential functions. So we already know that to find the inverse of any function, we must switch x and y and then solve for y. Now here's the example: y equals 2x minus 8. Switch the x with the y, you end up with x equals 2y minus 8. And then, actually doing the work here, you go plus 8 and then plus 8. So you get x plus 8, equals 2y. And then if you divide by 2 and divide by 2 and divide by 2, you'll get the final function right here. That's the inverse of the original. Okay, so what we're going to do is do the inverse of exponential and logarithmic functions, and to find the inverse of exponential or logarithmic functions, we also switch x and y and solve for y, but we need to know a few tricks to be able to do that. So the first thing to remember from Algebra 1 is that the first key point, you could do whatever you want to an equation as long as you do it to both sides. And here's the really interesting part that we're doing on today's section. You could magically add log base anything to both sides of an equation. Or you can raise both sides of an equation to be the powers of a base of your choice. Check it out. So let's say we had y equals 6 to the x. Right here we have y equals 6 to the x. Let's say they ask you to find the inverse. Well, you're going to switch the y with the x, and you'll have x equals 6 to the y power. Now we must solve for y. The problem is y is right here as an exponent. You don't want y as an exponent. So to undo an exponent situation, you're going to apply a logarithm to undo an exponent, because a logarithm undoes an exponent, and an exponent situation undoes a logarithm. So it says right here on our notes, we magically add log base 6 to both sides of this puppy, and watch the magic happen. So if I put a log base 6 right here in front of the x, and I put a log base 6 right in front of the 6, there it is, log base 6 right in front of the x, log base 6 of 6 to the y. The log base 6 of 6 cancel out, and the y is what's left over, and that's what comes down, and that's your answer. Okay, so what do we have? We have, as you can see, we have y equals, because the y came down, equals comes down, and what do we have? Log base 6 of x. And this is your inverse function of the original y equals 6 to the x. Let's do another example. It says, example number 2, find the inverse. Well, first of all, you're going to switch x and y. So instead of y, it's going to say x equals, and the y is in here now where the x used to be. And the thing is this: what we're supposed to do is solve for y, but y is inside a logarithm. It's really a log base e right there. Okay, so I need to get rid of the logarithm. To get rid of a logarithm, whether it's base e or base 2 or base 5 or any type of base, any type of logarithm, what you're going to do is raise both sides of the equation to be the powers of the base whatever you want. And in this case, we want base e because this is a log base e. So if I were to make it e to the x and make it e to the ln of y plus 3, then the e to the ln would cancel out. So what I did was I raised the left side to be the power of base e and raised the whole right side to be the power of base e. Let me rewrite it. E to the x equals e to the ln of y plus 3. So why would I do that? Because e to the ln is really e to the log base e, and e to the log base e cancels out, and the y plus 3 comes down. The equal sign's right here. The e to the x is what's on the left side. Now let me just get rid of the plus 3 by subtracting 3 on both sides. And there's my final answer, guys. Let me zoom out a little and write my final answer down here. It's going to be y equals e to the x minus 3. And that is the inverse function of the original. Okay. Now all of this work is explained. Let's go back to the notes here. It says magically raise both sides of the equation to be the powers of base e, and then it's continued on top of the next column. So if you move over and all the way up, it has everything explained for you right here. You will get e to the x and e to the ln of y plus 3. Of course, e to the ln cancels out, and the y plus 3 comes down. So you have your new equation, e to the x equals y plus 3. All you got to do is subtract 3 here, subtract 3 there, and you're done. You have your inverse function of the original, y equals e to the x minus 3. And that's the inverse function of y equals ln of x plus 3. Let's practice by doing a couple of these. So the first thing to do is to switch x and y. So it's going to be x equals log base 7 of y. Now you want to solve for y, but the problem is y is inside the logarithm base 7. So you want to get rid of this because you want y by itself. You don't want log base 7 right in front of y. So to get rid of a logarithm, you're going to have to raise both sides of the equation to become the powers of the base of your choice, and in this case it's going to be base 7. Put a big 7 right there. Put a big 7 right there, put the equal sign between the 7s, you could scratch this out. So you have a new equation that says 7 to the x equals 7 to the log base 7 of y. And what happens with the 7 to the log base 7? It cancels out. The y comes down, the equals comes down, and you have 7 to the x on this side. Ladies and gentlemen, we have the inverse function. The original function was a logarithmic function. The inverse is an exponential function. And that's always the case. When you take the inverse of an exponential function, you're going to end up with a logarithm. When you take the inverse of a logarithmic function, you're going to end up with the exponential function. Okay? So let's take a look at this next one. This next one has y equals 8 to the x. That's an exponential function. I'm going to end up with a logarithmic function when I do the inverse. Let's first start off by switching x and y. X equals 8 to the y. Now I'm going to solve for y. And of course, I don't want y in an exponent position. I need to get rid of this base 8. So how do I get rid of an exponential situation? By applying a logarithmic situation. So I'm going to apply a log base 8 here and also a log base 8 here. That way the log base 8 of 8 cancels out and the y comes down. And on the left side, you really do have that log base 8 of x. And there's your final answer for that one. More practice. Number 3. Well, I need to switch x and y. So that's going to be x equals e to the y plus 3. And now I need to solve for y. Now remember, I am going to apply a logarithm when I don't want the exponent. So right here we have a y that's in the exponent position. I am going to apply a log base what? A log base e, which is really ln. So I'm actually going to apply an ln on both sides. ln right there and ln right there. Now ln of x is exactly that, ln of x. But ln of e cancels out completely and the y plus 3 comes down. Now I need to solve for y, so I'm going to subtract 3, subtract 3. So my final answer is ln of x minus 3 equals y. And that's my inverse function. Now let's take a look at number 4. I'm going to switch x and y. So I'm going to have an x right here equals 2 to the y minus 3. Now I need to solve for y. Solving for y means get y by itself on the right side of the equal sign. You want y by itself. You don't want this minus 3, you don't want the 2. Which one is the easiest to get rid of? The minus 3. Get rid of it by going plus 3, cancels. What you do to one side, you do to the other side. So you're going to end up with x plus 3 equals 2 to the y. Now, you still want to get rid of that power of y. So how do you get rid of an exponent situation? By applying a logarithm. And of course, in this case, you're going to apply a log base 2. Log base 2. Log base 2. That way the log base 2 of 2, I know that this is all crammed, I'm sorry, but log base 2 of 2 cancels out, and the y comes right down, right? The y that was left over up here came down. I have the equal sign, and I have the log base 2 of x plus 3, but you have to put the x plus 3 in parentheses. Because if we go back to here, to the original equation, when I applied a log base 2 of 2, yeah, it canceled out, and what I do to one side, I have to do to the other, so I apply log base 2 over here, but it has to be of the entire equation. So if I had an x plus 3, I need to put it in parentheses to be able to take the log base 2 of the entire left-hand side. So I need to keep those parentheses. Final answer is log base 2 of x plus 3. And there's my final inverse of the original exponential function. Now it's very important that we understand that this guy needs those parentheses. If you don't have these parentheses on your answer, I will mark it wrong. Likewise, over here we didn't need parentheses. And the main reason is, on this one, the 3 was an exponent, and when we took the ln of e cancels out, and the whole y plus 3 comes down, and your final step on solving for y is to subtract 3, subtract 3. So you had the ln of x, and at the very end you subtract 3. That's why it says ln of x minus 3 at the very end. However, over here in this case, we first got rid of the 3 by adding 3 to both sides, added 3 here, added 3 there. And now when I did the log base 2 of 2, I needed to also apply log base 2 of the x plus 3, the entire thing. And that's why it has parentheses here. So I hope this helps. You guys really need to practice by doing the homework, page 504, numbers 37 through 44, all that's in the green book. I have posted the questions and the solutions from that green book on Edmodo here. So please make sure you practice and check those answers. All these questions will be on the test Friday.